question number 7 says integrate x upon x square plus 1 into x minus 1. Okay, so you have a quadratic factor in the denominator, you also have a linear factor in the denominator. The first and foremost important thing that we were supposed to note is whether it is a proper addition function, whether the degree of numerator is less than the degree of denominator. It says yes, the degree of numerator is less than the degree of denominator. Next thing, so we'll have to factorize the denominator which is already factorized. Oh, this is a quadratic factor, but mind you, this cannot be factorized further. Yes, the partial fractions of this particular will be written in a particular way. Let's see what that particular way is, because that's the next step, right? Converting into partial fractions, and then we'll go for integration, right? So what do we have? We have x over x square plus 1 times x minus 1. Okay, this will be converted to, one of the factors will be this x minus 1. So a over x minus 1 and plus, since this is not factorized further, you'll have x square plus 1 in the denominator over here, and in the numerator you have a linear expression, mind you, bx plus c. Okay, don't make a mistake over there. Okay, and in the previous questions we used some shortcuts, right? So here you can use that shortcut for finding the value of a, that is multiply throughout by x minus 1 and put x equal to 1. 1 upon 2 is what you'll get, that will be the value of a. But for values of b and c, yes, you will have to worry a bit. So for that, the original method, come back to that and see where does the take us. So this tells me that x, the numerator will be equal to a times x square plus 1 plus bx plus c times x minus 1. This is on comparison of the numerators. After taking LCM over here, the denominators get cancelled and you get a times x square plus 1, x minus 1 times bx plus c in the numerator, right? And now I can compare, since this is always equal to, this LHS is always equal to the RHS, I can compare these two and see where does that take me. So I have a, b, c as two unknowns, so I need three conditions. The three conditions would be coefficient of x square compared on the both sides, coefficient of x, coefficient of, constant term, right? So coefficient of x square over here is 0, which is equal to ax square, and bx square, this is a plus b. 0 is equal to a plus b. Coefficient of x is 1, which is equal to, over here, there's no x over here, there is minus bx plus cx, so this is c minus b over here, right? And the constant term, as you can see, is 0 on the left hand side. Constant term here will be a minus c. Okay, this is what you're getting, a minus c. Is that okay? Yes. So we can eliminate any two things for that matter. Let's say you can use these two equations to eliminate c and get an equation in terms of a and b. This is another equation in terms of a and b. Using those two, we'll get the value of a and b. So adding these two, what do I get? Minus c plus c will get cancelled. A minus b is equal to 1. This is what I get. Okay, and a plus b is equal to 0. This tells me, okay, a plus b is equal to 0. Using these two, I can add them and get the value of a as 1 by 2. Oh, but this is what we started with, right? Yes, yes, yes. So a is 1 by 2, that's clear. What is b? B, as you can see, will be minus a, which is minus 1 by 2 using this. What will be the value of c? C is equal to a, therefore c will be equal to 1 by 2. Those are the three values that you need, right? That's the first thing. So you have converted the complete expression into partial fractions. And this linear is very easy to integrate. This linear upon quadratic, we know how to integrate this one. Yes, linear upon quadratic can be integrated with the help of ideas which we have discussed in the previous exercise. That is, the linear, this numerator can be written as something times derivative of this denominator plus some constant, right? We generally use a and b over there. So this can be written a and b, since they have already been used over here, we'll use p and q, let's say. So numerator equals p times derivative of denominator plus q is what you'll use over here, right? So that's the next step. Let's write the integral I, which is equal to this, or that becomes equal to what? That becomes equal to a upon x minus 1, integral of a, which is 1 by 2 over x minus 1 plus bx plus c, which is minus half x plus c, which is half upon x square plus 1 dx. This is what you have, right? This is what you have over here. Okay, what else? So this can be integrated easily. Half times this becomes log modulus x minus 1. This integral is very simple. and you can take out a half common from here. Exactly, you can take out a minus half common from here, so it becomes minus half integral of what remains is x minus 1 upon x square plus 1 dx. Okay. Now this x minus 1 has to be written as p times, or what we used over there was a times derivative of this denominator plus some b, right? So let me rewrite that x minus 1 as a times derivative of this, which is 2x plus b. And once again comparing tells me that, comparing both the sides tells me that 2a will be equal to 1, a will be equal to 1 by 2 over here also. Okay, but we have used a, b and c over here, so why are you using a, b, c over there also? So this particular calculation can be done in the rough as well. Okay, that's one of the ways, or you can use different variables. In the past we have used a and b, but here what you can do is you can use p and q as well. Doesn't make a difference. We are supposed to find the values of p and q, and let's do it. So 2p is equal to 1, which implies p is equal to 1 by 2, and q is equal to minus 1. That's what you can observe. Q is equal to minus 1. So using these values, I can write that second integral in terms of these two values. So therefore I, which is equal to half times log modulus x minus 1 minus 1 by 2 is okay, and this integral will be separated as half times 2x, okay, half times 2x, and you have minus 1 which is extra, so minus 1 upon this, upon x square plus 1, that's one term, and you have minus 1 upon x square plus 1 times dx. This is what you get, right? That's the complete integral. So this x square plus 1, if it is substituted as t, this 2x dx will become dt. So this is dt upon t. Integral is pretty simple. Yes, half is okay, log modulus x minus 1 is okay, minus 1 by 2 is okay. In the bracket, what will we have? This is half, okay, and this becomes dt upon t, which is log of mod t, or log of mod x square plus 1. This minus half remains as it is, and you have this particular term. Integral of this is nothing but tan inverse x plus a constant term, and yes, that is my final answer. Or you can just multiply this half inside and see, this is half log of modulus x minus 1 minus 1 by 4 log modulus x square plus 1 minus of half into minus 1 is plus 1 by 2 tan inverse x plus constant. That is my required answer for this particular question, 7th. As you can see, the complete solution over here. Question 8 says integrate x upon x minus 1 square